All right, hello everyone and welcome. If you're gearing up for your OCR GCSE in computer science, you have definitely come to the right place. In this explainer, we're going to jump right into a really key topic from Component 2, Section 2.5, which is all about programming languages and IDEs. Let's get right into it. Okay, so let's start with the big problem, right? At the very core, computers, or more specifically, their CPUs, only understand one thing: machine code. And that's literally just long strings of ones and zeros. But that's not how our brains work at all. So the massive question is, how on earth do we cross that communication gap between us and the machine?
And the answer to that puzzle? Well, it's programming languages. These are the brilliant tools that act as the bridge. They let us write instructions for a computer in a way that actually makes sense to us humans, which can then be turned into something the computer can finally understand and execute.
Now, it's not a one-size-fits-all thing. For your exam, you've got to know about two main flavors: high-level and low-level languages. And the best way to picture it is like a spectrum. At one end, you have languages that are really close to how we speak and think, and way down at the other end, you have languages that are practically whispering in the machine's ear. Okay, so let's really get into the nitty-gritty here, the stuff you absolutely need to remember. High-level languages, think Python, think Java, are designed to be easy for us to read and write. A huge plus is that they're machine independent, so your code can run on lots of different computers. But low-level languages like assembly code, they're pretty cryptic to look at, and they are completely tied to one specific type of CPU. You'd use them for super specialized things, like writing device drivers where you need total control over the hardware. Okay, but here's the catch, and it's a big one. Even when you write your beautiful, readable, high-level code, the computer still has no idea what you're talking about. Every single line has to be translated into those ones and zeros before the CPU can do anything. And that leads us perfectly into the next thing you have to know for the exam: translators. So to get this translation job done, we have two different tools in our toolkit, and you've got to be able to compare and contrast them. We're talking about compilers and interpreters. But before we dive in, what even is a translator? Let's just lock down that definition. Simply put, it's a program that takes our source code, the stuff we write, and converts it into binary machine code, the stuff the processor can actually run. Think of it as the ultimate middleman, the essential link in that chain from human to machine. You know, the easiest way to get your head around the difference between these two is with a simple analogy. Imagine a compiler is like a book translator. They take the entire novel, translate the whole thing from cover to cover, and then give you a finished translated book. An interpreter, though, is more like a live interpreter at a meeting. They translate what's being said sentence by sentence in real time. So let's look at the compiler first. How does this thing actually operate? Well, it reads your entire program file in one go. Then it translates the whole shebang into a single, separate file of machine code, which we call an executable. And here's a key detail. If it finds any errors, it just keeps going. And then at the very end, it gives you this massive list of every single mistake it found. If there are no errors, you get that executable file, which can run all by itself. All right, now let's flip the coin and look at the interpreter. It is a completely different beast. It takes just the first line of your code, translates it, and runs it right away. Then it moves on to the second line and does the same thing, over and over. But the second it finds an error, bam, it just stops. The whole program grinds to a halt right there. This line-by-line approach has some really big implications. Okay, so this is the big exam slide, really. These differences create some really important pros and cons you have to know. Compiled code runs much faster because all the translation work is already done up front. But interpreters are brilliant for debugging because they stop you right at the line where the problem is. With a compiler, you get a standalone file that's easy to give to other people. With an interpreter, you always need the source code and the interpreter itself to run the program. This often means that when you're actually building the thing, an interpreter can feel way faster because you can just run, test, fix, and repeat in a super quick cycle. So you might be wondering, where does all this coding and translating actually happen? I mean, programmers aren't just typing into a blank notepad, right? Of course not. They use a really powerful piece of software called an IDE. IDE stands for Integrated Development Environment. It basically brings every tool a programmer could possibly need all under one roof. That analogy of a programmer's workshop, it's spot on. It's the one place where you've got everything you need laid out and ready to go. So what exactly is inside this digital workshop? Well, for your exam, you need to know about a few key tools. First, you've got the editor. This is where you write your code, but it's a smart editor with features like syntax highlighting to make things clearer. Then you have error diagnostics, which are basically your little helpers, flagging up typos and errors as you go. You've also got a runtime environment, which lets you run your code right there in the IDE to see what happens. And finally, the translators, the compiler or interpreter, are built right in. You just click a button, and it does the translating and running for you.
Phew! Okay, that was a lot to take in. So let's boil it all down. This is your final exam checklist for Section 2.5. Think of this as the absolute must-know list. Ready?
Right. Make sure you can explain the characteristics of high-level versus low-level languages. You need to know the purpose of translators. You have to be able to describe the differences in how compilers and interpreters actually work. Then you need to list the pros and cons of using a compiler and the pros and cons of using an interpreter. And finally, you have to know what an IDE is for and name its key tools, like that editor and the error diagnostics. Got it? Okay, I want to leave you with a final question to chew on. Something to really test if you've got this. Based on everything we've just talked about, especially about finding errors and how you develop code, which one do you think is better for a total beginner? Someone who's just learning to code. And more importantly, why? Give that some thought. That's all for this one. Best of luck with your revision.